Good morning, students. Today we are going to see the program implement and analyze Dijkstra's algorithm to find the shortest path from a given source. So what is the purpose of Dijkstra's algorithm? We already discussed in class. Dijkstra's algorithm is going to find the shortest path from the source vertex to all other vertices in the graph. So we'll just check it out how the program works. So as you know, every time when we wanted to give input as a graph, we are giving the input using the adjacency matrix. So to hold the adjacency matrix, we are having the two-dimensional array A and we are declaring all other required variables. Now entering the number of nodes, how many number of vertices are there in the graph, that is saved in the variable En. Then enter the adjacency matrix. This is the input. The adjacency matrix is the input that is representing the graph and that is saved in the variable I. Now, according to Dijkstra's algorithm, it is from one vertex to all other vertices. So we have to enter what is the source vertex, and the source vertex is saved in the uh, variable V. Now we are declaring two arrays. One is S and one is D. S is the array S is declared as 0. Okay, so array S is just like checking that whether you visited that particular vertex or not. So initially the entries are zeros, that is representing that we are not visited the vertices in the graph as of now. And D is the distance vector. Okay, D is the distance vector. So what is the initial value of D is? We know that we know that V is the source vertex. So what is the direct distance from source vertex to all other vertices that will be saved in the array D? Now we know that first is the source vertex. So we are marking in the S array source vertex as 1 because it's already visited. Now we are going to find what is the shortest distance from the source vertex to all other vertices. Okay, so source vertex is represented as V. And we are marking S of V as 1. Now we want to know that what is the shortest distance from source vertex to all other vertices. For this, first we need to find which is the shortest path from the source vertex, or which is the nearest node from the source vertex. So we are going to find that particular node. So we are going to initialize minimum as 999. Okay, 999 as minimum, and after that we are checking each entry in the D array with this 999. Okay, and if it is less than the 999, we are making it as min. And one more condition is there: if the vertex is already visited, that means S of I is equal 1, no need to check because that vertex is already visited. Otherwise, whenever we are getting the minimum value, that will be stored. So instead of 999, what is the minimum? For example, 2 is the vertex 1 to 2. The distance is 2. So that will be the minimum, and whatever the vertex that is having minimum value, that will be represented as U. So when you are executing this particular loop in one time, it is like you are getting the shortest distance from the source vertex to the other vertex. Suppose it can be 1 to 2, 1 to 3, which is the shortest one, that we are getting the minimum value and that particular vertex also. Now that whatever the minimum value you got, that vertex is visited. So it is marking as 1. Now what we are going to find is, we are going to find whatever the new vertex you are finding, whether we are getting a shortest path from the source vertex through the new vertex. Okay, so we are going to check if I'm going through the direct path, whether that is minimum, or if I'm going through that intermediate vertex, that is minimum. So if you are getting an intermediate vertex minimum value, that will be replaced. Otherwise, the original value will be replaced. So this loop will be continuing until all the vertices are visited, and the final output will be replaced every time. It will be replaced in D array, and the final output is stored in the D array. So this is the Dijkstra's method. Now we will see the execution of Dijkstra's method. Yeah. So program is copied here. We are going to execute the program. When you are running the program, the first it is asking how many number of nodes. For example, suppose I'm giving the number of nodes as 5. Okay, so n is equal to 5, and enter the adjacency matrix that is representing the graph 0, 20, 5, 25, 999. 999 is representing if there is no path between vertices, it is infinity. That infinity is represented as 999. For example, this is 1 to 1 0, 1 to 2 20, 1 to 3 5, 1 to 4 25, 1 to 5 there is no direct path. So we are representing it with the 999, a large value. Next is 20, 0, 999. That means there is no path. 999, 10, 5, 999, 0, 10, 999, 25, 999, 10, 0, 15. And the last from vertex 5, this 999, 10, 999, 15, 0. So adjacency matrix is entered. Now it is asking for the source vertex. For example, I'm giving vertex 1 as the source vertex. So the shortest path from vertex 1, output is vertex 1 to 1, it is 0, 1 to 2, 20, 1 to 3, 5, vertex 1 to 4, 15, vertex 1 to 5, 30. Distance is 30. Okay, so you can execute the program. Yeah, I think before whatever I was explaining, screen was not visible. Sorry. This is the program. Okay, this is the program. I executed the program. As I explained earlier, the number of nodes entered is 5. I'm entering the adjacency matrix. I think the screen was not visible to you. So now please check it out. 999. Okay, 999 is representing there is no path, that is infinity. So 5 nodes. So this is from 1 to all other vertices 2, 3, 4, 5. Now it is asking for the which is the source vertex. Source vertex is entered as 1. Okay, so it is giving the distance from 1 to all other vertices 1 to 1, 1 to 2, 1 to 3, 1 to 4, and 1 to 5. Okay, so you can execute the program, go through the program, and trace the program once. If you have any doubt, you can let me know.